Hello everybody, my name is Barisha and we are still in business of describing NVIDIA Orin system on chip, or generally we are talking about system on chips. Orin system on chip have three separate blocks: CPU, GPU and accelerating block. CPU block is divided in three clusters with four cores. So in total it's 12 cores, but we will see a story about that a little bit later. Also we have a GPU block which is made of two GPCs with 8 streaming multiprocessor, and we can remember or remind ourselves to that the GPC is actually graphic processing cluster. It's an inherited name from the GPUs which are used in PCs, and we have a special accelerating block which is consisting DLA, PVA, HDR, ISP or image signal processor, video decode, and video encode. We have different kind of L1, L2, L3 cache memories. This will be mentioned later as a L4 memory, but we will discuss about that later. And we can see here that a common L2 memory for this and this GPC is this 4 megabyte memory, and for each of these clusters we have L3 cache which is 2 megabyte each. Also, we didn't mention in the video on Serbian, but we have some safety island, and we will talk about that later. And so that's all interesting things that we can see in this slide. So we can go further. Also, we can talk about first part of our first block inside this system on chip, Orin. It's a CPU complex with, as we said, three clusters with 4 cores each. As you can see, 3 clusters, 1, 2, 3. Also common 4 megabyte system cache. And inside of each cluster we have 2 megabytes L3 cache for whole cluster, which is meant to be approach from all these 4 cores. And also inside the one cluster, each core has its own L2 cache and L1 cache divided into parts for the instruction cache or instructions and data. So this is L1, this is L2, common for this L1 cache meant for this core. L3 cache is meant for all 4 cores or total 4 cores inside this cluster, and common for them is this 4 megabyte system cache, which I think it's called L4 or something like that. Yes, that's what it says here. We have description here of which kind of cores are here inside the clusters. It's an ARM Cortex A78 V8.2 high performance CPU. Also Lockstep support. We will see what does it mean. This is the frequency, and we have this cache hierarchy which I already mentioned here. Instruction and data, and lockstep mode means 2 CPU cores execute same instructions simultaneously and compare result in real time. So in automotive industry, it's common need to have, let's say, some redundancy and some security, and to be sure that we are using proper data. So probably this is a parallel instruction and compare results of some derivation and instruction execution. So let's go further. A second block is actually is GPU section or block. What can we say about that? We can see that also here is 4 megabyte L2 cache. We have a GPC 1 and 2, so it's divided inside this let's say inside of this block we have two separate GPC or graphic processing clusters, which has 4 TPCs or texture processing cluster, and each of them has 2 streaming multiprocessors. And this is the, let's say, best and most useful option of the chip. Maybe it has some reduced resources, but it's another story. This is, let's say, chip in full capacity, and let's see what is actually said here. Orin features the Ampere GPU architecture with enhanced DL throughput. I'm not sure what this DL means. The latest graphics capabilities, including ray tracing. Yes, ray tracing is also present in classical GPU units, and improved power efficiency. This is very interesting. Maybe these cores are power efficient more inside of this system on chip rather than classical ray tracing cores. So, as we say, 2 GPCs, inside of them there is 8 TPCs. So inside of them, that TPCs in total, there is 16 SMs. I'm not sure what this means, 2 times Xavier, maybe some model or whatever. This is the side of the L1 cache, which is dedicated to the stream or each the streaming multiprocessor. This is side of it. And we have 4 megabytes L2 cache, we can see it here, and enhanced tensor cores. So probably some tensor core with very good characteristics, but we will see that details in later videos. Okay, let's go to the block, which is third block. We mentioned that we have DLA inside of it. It's next generation DLA, blah blah blah. Okay, what does this DLA means? It means deep learning accelerator focused on integer 8 inference performance. Inference is conclusions, as we mentioned in previous case, and it seems that it's capable to work only with integer 8-bit numbers, but we will see that later. We have a short description of this part of this block or its architecture. What does it consist of? Increased performance. We see this is some, let's say, deep learning accelerator. This is maybe some kind of pre-processing or what it is, we will see later. For the video signals, aligned with the GPU compatible math pipeline structured Sparticity Tensor RT-AP. This is very popular. Maybe it can be approached with the TensorFlow, which is part of the Python. But we will see. This is very interesting. Performance structured sparsity. I'm not sure what does it means. Larger SRAM. Hardware support for layer scheduling, dedicated to depth-wise convolution engine. When we see convolution, we can conclude that this is doing some work for the maybe convolutional application of convolutional neural networks. but we will see. But this is very indicative that it has some kind of dedicated part for that. Additional native hardware features supported. It's pretty much unclear, but we will see later in details. It's very important to mention what it is. Once again, it's a deep learning accelerator for deep learning. Here is mentioned that the DLA consists of microcontroller, depth-wise processor. Very interesting. No detailed information about this. Hardware scheduler. 608 kilobyte buffer, convolution core, post-processing, memory interface or whatever. So for now, on the first watch, it's very unclear, but we will see and learn about this through the details. It's very important to mention this. On the next slide, we have another part of the third block. It's a PVA. PVA means Programmable Vision Accelerator, and this is the Programmable Visual Accelerator. It has some kind of core. I'm not familiar with this. Core Cortex R5, some instruction cache, some data cache, TCM. I'm not sure for this. Direct memory access controller. This is some kind of, let's say, probably when I see DMA controller, I'm guessing that this is some kind of distribution and redistribution of the data for the maybe pre-processing, video pre-processing or whatever. We also here we have VPU, two of them, and another block of the this is VPU memory, and different kind of transmission of the data in circle between these parts of the PVA system, which is Programmable Vision Accelerator. Also, maybe this is like universal chip, that there is some programmable logic part, and this is analogous of that part or of that block which is inside of the Versal, but we will see also. VLIW, very long instruction word. We can see it here. Maybe it can work with very large words. And we have VIC, means video imaging compositor, or VIC 2D engine. The best way to check what it is to go into the details, but we need to mention this. We can go to previous slide and say that DLA and PVA are part of the third block, which is meant to be used probably for some kind of or different kinds of pre-processing of the video, and help to do some, let's say, transformations of the video signal that we get from the input of this system on chip. But let's not let's say philosophize about this. We will see in details later. This is just getting better in knowledge of basic architecture of this system on chip and its capabilities, and we will see later applications what can we use it for. But what I see from the internet, it's mostly for the video processing. Also, we mentioned up there Orin Safety Island. Let's go back and check where it is. Yeah, this is a separate part. This is like, maybe we can say, fourth block, Safety Island, and we can see what it consists of. Orin Safety Island, it has isolate ASIL compute subsystem. Okay, this is very important for the automotive industry. Also, on the Versal chip, we see that it's ASIL D capable. So we see that this is a chip meant to be used in automotive industry. Lockstep ARM Cortex R52 CPUs. How many of them? It seems that it's two of them. I think that we saw that in inside Versal there is two R53 uh, cores, or maybe three or four. I'm not sure. And maybe we should check what is the real purpose of this R52 or R53 cores. Also divided L1 cache, 32 kilobytes, and the instruction and data 512 kilobytes of tightly coupled memory, safety island fabric. It sounds familiar, but I'm not sure. And security engine, DMA, direct memory access, and we see that we have here different kind of interfaces: SPI, CAN, UART, GPO, hardware sync, IPC timers. It's all part of Orange Safety Island. What is the real purpose of this? Maybe this is some separate part, but maybe this is some kind of crypto engine for the encrypting communication, which is going through this. But we will check that. Maybe this is part. Maybe this is part for the interconnection with two Orin system on chips, but we will check that. We don't know that for sure. And this is maybe the last slide. It's here is Orin system on chips. This is from the AGX, but we can see here the blocks that we mentioned much more clear. 12 cores of A78 IA CPUs divided in 3 clusters with 4. Also 64 gigabytes of DRAM. I'm not sure again is it on a chip or separate. Also 2048 in best option of CUDA cores with Ampere architecture. Why does beside of this CUDA cores we have 64 tensor cores, which is very useful to know, because we can derive and make calculations inside of the CUDA cores or inside of the tensor cores. We also mentioned that in previous videos. It says that these 4 megabytes of that cache is maybe joint for the CPU and GPUs, but no, we can see that this is probably L4 cache and this is L2 cache just for this memory controller fabric. I didn't saw this in this microcontroller. We also have PVA here, image signal processor, compositor, we mentioned this, APA, SPI, blah blah blah. Communication, I2C, SPI, CAN, GPIO, general purpose input output, UART, and I2S. We see here that we have a USB or PCIe. Maybe this is first generation, but I'm not sure. Also, it seems 5 links to PCIe with speed of 1 time 10 gigabits, and so on. So this is let's say short overview. We have HDMI. I'm not sure this is DP digital processing, whatever. But this is much more, let's say, clear image and representation of previous blocks that we mentioned. So, nothing more to add. This is just short review. I hope it was short review of elements which are part of the Orin system on chip. And we will later go into the details about these components which are mentioned here. We mentioned here in details about CPU and GPU on Serbian. Maybe the best thing is to focus on the application of this chip and to focus on this accelerating block and see other blocks, and let's say give more clear picture how to properly use, and also to see what is the system architecture on this chip. So that will be all for today, and greetings to everybody. Until next time, bye bye.